Welcome! So today, we're going to pull back the curtain on the secret rules of math, the ones you've been using your entire life, probably without even knowing their names. These are the invisible rules that really are the backbone of algebra.
Okay, let's just dive right into this, because it's absolutely true. Just think about it for a second. When you're at the grocery store, you know that adding the price of the milk and then the eggs is the exact same as adding the eggs and then the milk. You don't even have to think about it, you just do it.
Well, that simple fact actually has a name. It's called the commutative property. And that's really what today is all about. We're going to give official names to these rules you already know and show you how to use them on purpose to make math a whole lot easier.
So here's what we've got on tap. We'll start with why these rules matter in the first place. Then we'll meet the key properties. We'll put a spotlight on the MVP, see how they create some serious mental math magic, and then we'll finish up with a few common traps you'll want to avoid.
So why even bother putting names to these ideas? Well, it's because once you can name them, you can use them on purpose. You go from accidentally being right to strategically solving problems. And that works whether you're trying to ace a test or just quickly figure out a budget in your head.
All right, let's officially meet the team. There are a few core properties that are the foundation for how numbers work together, and believe me, they do most of the heavy lifting in algebra.
Okay, this slide right here, this is our playbook. It shows how each property has a version for both addition and multiplication. It's a fantastic cheat sheet. But for now, let's just zoom in on the two that people mix up the most often. First up, we've got the commutative property. You know, the best way to remember this is to think of the word commute. When you commute to work, you change your location. With the commutative property, the numbers change their order. Simple as that. Next is the associative property. For this one, think about your associates, the group you hang out with. With this property, the numbers actually stay in the exact same order, but you change which ones are grouped together inside the parentheses. So here's the crucial point. Commutative swaps the order. Associative shifts the groups. See how in the associative example, the 2, 3, and 4 stay in the same sequence? It's just the parentheses that move. Getting these two mixed up is such a classic mistake, so this is a really good one to remember.
Now that we've met the team, let's talk about the absolute superstar of the group, the distributive property. Yeah, this one is so important, it gets its very own section.
And you know what? That is not an exaggeration. The distributive property is this incredibly powerful tool you will use constantly as you solve equations. It's really the key that unlocks more complex algebra. And this just illustrates its power so well. It's the only property that acts as a bridge connecting multiplication with addition. I mean, think about it. If you're calculating a 20% discount on a shirt and a pair of pants, you could add the prices and then take 20% off, or you could distribute that 20% discount to each item first and then add them. You get the same answer. Let's see it in action.
So to simplify 4 times the quantity x plus 3, we just share or distribute that 4 on the outside to each term on the inside. That gives us 4 times x plus 4 times 3. Clean that up and you get 4x plus 12. It's a really beautiful, simple process.
So, why are we drilling these names? Because knowing them gives you what I like to call mathematical superpowers. Seriously, you can start solving problems in your head that used to seem totally impossible.
Now at first glance, this looks like a job for a calculator, right? But what if I told you that you could solve it in like 3 seconds using the properties we just learned? Okay, watch this. First, we're going to use the commutative property to swap the 37 and the 4. Now, why would we do that? Because our brain knows that 25 times 4 is a super friendly number, 100. Then we use the associative property to regroup, to put those parentheses around the 25 and 4 so we can tackle that easy part first. And just like that, a tough calculation becomes 100 times 37. The answer is 3,700. No calculator needed. That right there is the real power of knowing these rules.
Now, knowing what to do is really only half the battle. It is just as important to know where these rules don't apply.
The biggest trap, by far, is trying to use these properties with subtraction or division. They just don't work. I mean, 5 minus 3 is 2, but 3 minus 5 is negative 2. These rules are exclusively for addition and multiplication. And always, always remember the difference. Commutative is for order, associative is for grouping.
And as we've seen, this isn't just abstract textbook stuff. When a cashier gives you change, they might group the coins in a way that's easier to count. That's the associative property in real life. When a programmer optimizes code, they might reorder operations to make a program run faster.
You are literally using these rules all the time.
So, the key takeaway here is this. By understanding the why behind the math, the names, and the rules, you unlock these incredibly powerful new ways to figure out the how. So the next time you see a long string of numbers, don't just automatically reach for the calculator. Ask yourself, can I reorder this? Or can I regroup this to make my life just a little bit easier?